Okay, let's take a look at Lab 2, and this is found in our Week 2 module. You'll scroll down, you'll see a section for the second lab. And here are the labs themselves. You want to download it in either Word or PDF, depending on what you're more comfortable with. You'll also want to download these 4 maps while you're here, because these are files that you're going to be using for the lab. Okay, so let's look at the lab itself. So we're going to be looking at plate tectonics. We're going to start by looking at a global view of plate tectonics, and then we're going to zoom in a little more closely to the Pacific Northwest. So we're going to start by looking at this map, and this is a map of the divergent plate boundaries. And now this is all going to be a lot easier if you have completed the reading, the lectures, and the homework before diving into this lab. So our divergent plate boundaries, these are boundaries where the plates are moving away from each other, and that's what's shown on these maps. You'll see that there is a dark line kind of wiggling its way up and down the Atlantic and around different parts of the world, and that is the location of divergent boundaries. You'll see that there's other boundaries too. The thin lines, those are ones we'll deal with later, but now we want to just focus on those divergent boundaries. So your job is to find where these divergent boundaries are and then look at those locations on the other maps and see what's going on with the geography, the geochronology, seismology, and we're also going to be looking at volcanology. So we found a nice divergent boundary going up and down the middle of the Atlantic. And we are going to look at first our geography map and see what's going on with the elevation or the bathymetry of the locations where there's a divergent boundary. Elevation is what we call it when it's on the continent. That's how high the land is. And remember, bathymetry, that is the depth of the ocean. Our key on the right here is going to tell us what all these colors mean. And you can see as you get down to these pink colors, those are the deepest areas of the ocean. And so we find a divergent boundary going right up and down the middle of the Atlantic. That's what we saw on our previous map. And so your job is going to be interpreting this data and giving a description of what's going on there. And so you're going to answer a series of questions about divergent boundaries based on this data. You're also going to be looking at geochronology. What this is showing is the age of the sea floor. And so again, you're going to find your divergent boundary and you are going to give a description of the age of it. And remember to look over to the right to see what these colors actually mean. Note that in each of these maps, it's kind of in the fine print, but it's telling you what the units are for this key over here. It says seafloor age in millions of years. Likewise, you'll have to check the units for the geography map too. So you'll answer some questions about geochronology. You might have some questions about volcanology, and you'll use this map. This is telling you the location of the world's volcanoes. And you'll have some questions about seismology. These are showing the locations of earthquakes. Each dot represents an earthquake, and the color is telling you the depth. So you'll have to figure out what those colors mean right here. Okay, so that is going to get you through this part on divergent boundaries. This next part is a similar map, but now we're looking at convergent boundaries, where those plates are moving towards each other. And so again, these thick lines are representing convergent boundaries, the thin lines representing other types of boundaries that we don't have to look at right now. And note on this map, there are 2 different types of boundaries. There's type A boundaries, and there's type B boundaries. We're going to be mainly focusing on these A boundaries, and a great one to look at is on the west coast of South America. But there are a few questions about B boundaries. Look at this location when you're answering questions about B boundaries. That's the best place in the world where we have an example of a type B convergent boundary. So similarly, you find the location of a convergent boundary, and then you go to these series of maps to see what's going on with the different features like elevation or bathymetry or earthquakes. and you'll answer some questions. Then you'll get to part 2 where we are taking a closer look at the Pacific Northwest. And so this map should look familiar. Last week we were looking at geography, but this time we're looking specifically at tectonics. And so you're going to be using a couple of resources. First is that geologic map that we looked at last week, the one that looks like this. And remember, each of these colors represents a different type of earth material, whether that be rock or sediment or something like that. And then these colors are described over here, and it tells you what exactly that material is. So that will be a helpful resource, and this one will be an even more helpful research. This is from Portland State University, and it has a lot of the information that you will need for this exercise. Okay, so you label the features that it's asking for up here on the map, and then you move on to part 3. And again, we're using that geologic map to answer a few more questions. And finally, part 4 is we're going to be looking at earthquake data. Now, this is a little bit more geology than true oceanography, but it's so important, relevant to the Pacific Northwest that I thought I'd include it. And basically, this is a timeline of all the major earthquakes that we've had in our region. And you can see that it goes back 8,000 BC and goes all the way to modern day. And each one of these red lines is an earthquake. These thick ones are going to be our 9.0, our huge, massive earthquakes. And then our smaller lines here are going to be our 8.0 earthquakes, slightly smaller, but still absolutely destructive. And so you're going to interpret this chart, answer a few questions, and note that when we say 8.0 or greater, that includes our 9.0 earthquakes as well. So you're going to be calculating something called a recurrence interval. And this is the average time between earthquakes. So you're going to have to figure out how many years are on this timeline, along with how many earthquakes there are. And you should be doing some calculations to figure out what this recurrence interval is. On this part, if you're having trouble, feel free to reach out to me. This is one, if we were in class, I'd be coming around and helping everyone out with if you're struggling. Okay, and then finally, you're going to look at a couple articles. This first one, you're going to compare your recurrence interval to the recurrence interval calculated by the experts. And then finally, you're going to be going to a cool website where you put in your zip code or address, and then this website will tell you what it's going to be like after a major Cascadia subduction zone earthquake. And it's going to tell you some pretty startling, I guess to put it lightly, information about when things will be getting back to normal. Okay, so when you've completed your lab, you're going to submit it right back here in this Lab 2 area. On your side, you'll see a submit button. As always, feel free to reach out to me with any questions, and I will be available at 3 o'clock on those Tuesdays and Thursdays to kind of help you through it. All right, good luck. Be sure to reach out if you need help.